Bismillah. Hello, this is the continuation of our lecture. This is in Matlab course, lecture number 9. As usual, we shall solve these simple questions. These are a little preliminary, therefore I will go a little fast. Let us calculate these expressions. So I will take 16.5 power 2 multiplied by 8.4 minus square root of 70. This is the bracket for square root and this is the bracket for the left one, and this entire term is divided by this entire denominator. The denominator consists of 4.3 whole square minus 17.3. Right. So this is the expression how we write in Matlab. The answer is 7.6412. Now let us calculate this one's sine of 7 pi divided by 9. In Matlab, pi value is already built in. Pi is equal to 3.14. It is a reserved word. Right. Now let us calculate the second one. Therefore, I will take two terms. This I will take as a term. This I will take it as a term. Therefore, x is equal to sine of 7 multiplied by pi divided by 9. And so this is then the whole divided by cos of 5 pi, 5 multiplied by pi divided by 7. For this we find the square. Alright. So this one cos square of 5 divided by 7 into pi, or 5 pi divided by 7 whole square. Alright, this is my x, and my y value is equal to this one tan 5 pi by 12 divided by 7. Therefore, tan of 5 into pi divided by 12, this is inside tan, then entire thing is divided by 7. Alright. Now I want x plus y, therefore x plus y is equal to this. The value of this expression is 2.1867. Right, now coming back to the next question. The next one is define the variables x is equal to. So, sorry, this one, the second question is define the variables x is equal to 8.3, y equal to 2.4. Then calculate this expression. Yes, it is. This is also simple. So let us define x is equal to 8.3. Therefore, let us clear the memory locations and clear the command window. Now, second question, x is equal to 8.3. Okay, then y is equal to 2.4. Okay. Now we want to evaluate square root of sqrt of x multiplied by y. Alright, minus sqrt of the second term is x plus y. Okay, then plus, then the whole bracket. For this whole bracket we apply the square, and that whole bracket consists of a numerator divided by a denominator. Alright, what the numerator contains? The numerator contains, for visibility are given, this is x minus y, the values are substituted, divided by x minus 2 into y, 2 multiplied by y. Alright, so this is the third term. Then minus, for the entire thing, square root of x divided by y. Alright, so this gives me the answer 2.1741. Alright, then the question number 3. The question number 3 says the arc length of the parabola segment BOC. Therefore, this one, BOC, this length BOC, this length is given by the formula, this one, where ln means it is log, this is square root. Calculate the arc length if A is equal to 12. This length, almost this is the semi-major axis, and this one is the minor axis. B is equal to, not full thing is, B is 8, and this length is equal to 12. And now we have to find this arc. Right, we can assign the values of A, B, and we can substitute the formula. Right, so again as usual I can clear the command window, clear the memory locations. Now A is equal to 12 and B is equal to 8. B is equal to 8. Alright, that is what it is given, A and B. Now we want to calculate S, therefore S is equal to, therefore let us first calculate this term. This term is equal to square root of B square minus 16 into A square, 16 multiplied by A square, and that square root is divided by 2, then plus, then this value is equal to B square, therefore B square is multiplied, therefore B power 2 multiplied by this value is log, therefore log of this entire term. What the log consists of? Log consists of 4 multiplied by A plus square root of, this is the bracket for the square root, so the square root consists of B square plus 16 multiplied by A square, this entire term, therefore I will put one more bracket, this entire term, this one, this is the current, okay, log of this entire term is divided by B. Alright, then this one, the whole term is divided by 18. Alright, so it looks a little complicated, therefore what I will do is I will skip this one, I will skip this. Let us calculate in terms of two terms. So first I will calculate term 1. T1 is equal to square root of SQRT of B square B power 2 plus 16 multiplied by A square. So this is the square root divided by 2. Alright. Then term 2 is equal to, I will take only this term, B square into 18. Therefore B square divided by 8 multiplied by A. Alright. Since both have equal priority, whether you put a bracket or not, I will put a bracket for clarity. B power 2 divided by 80. This is my term 2. I will take this one is equal to term 3. Therefore T3 is equal to log of, this is the bracket for log, and inside the log what it contains numerator by denominator. Therefore this is numerator divided by the denominator is B. Alright, now what the numerator contains? The numerator contains 4 multiplied by A plus square root of B square B power 2 plus 16 multiplied by A power 2. Alright, so if I keep this one, if I move this, yes, the bracket corresponds. This one I have to put one more bracket for the log. Alright, now what we have to do is the value S is equal to T1, the first term, plus the second term T2 multiplied by T3, because T3 consists of log term. See that these two terms are multiplied. Alright, therefore the length of the arc is equal to 26.9914. Then let us go to this question. How many boxes are needed to pack 4,000 oranges if 52 oranges are placed in each box? 4,000. One box can contain 52 oranges. Therefore the only thing is we have to divide 4,000 divided by 52. Therefore let us come back here, let us clear it. 4,000 divided by 52 will give me a fractional number. There cannot be 76.9 boxes. Therefore I have to make it 79. I cannot use integer. A higher number is ceiling. Ceiling of 4,000 divided by 52 should give me 77. Therefore 77 boxes are required for packing 4,000 oranges if each box consists of 52 oranges. Here the purpose of the question is to know whether you can use the proper function of the ceiling. Alright, now next question. Show that the sum of the infinite series 1 by 2, 1 by 2 square, 1 by 2 cube up to 1 by 2 power n, because n is equal to 10, but 2 power 10 converges to 1. So the question is, so likewise this converges to 1. Alright, therefore we want 1 by 1, that is 1 by 2, 2 power 2, 2 power 3. Therefore 1 by 2 is common, the power is 1, 2, 3, 4 up to that. Therefore let us take a vector. So for this, answering this question, we want this is 2 power 1, 2 power 2, 2 power 3 we want. Alright, therefore we shall take this one. I will take this. N is equal to a vector from 1 to 10. Alright, now I want 1 by 2, 1 by 2 power 2, 1 by 2 power 3, 1 by 2 power n. Therefore I will take 1 divided by 2 power n. This will give me an error. We are doing error and trial method. 1 by 2 power n. N is a vector, therefore it will report an error. Therefore the actual answer should be 1 by 2 power n. Therefore, 1 divided by 1 is also a vector. 1 divided by 2 power n, this is 1 term. 1 divided by, because the n happens to be a vector. Right, 1 by 2 will give me 0.5. 1 by 2 square, 1 by 2 square means this one is equal to 4, and this is 1 to 5. Now for this we have to add. Therefore now this series is in the variable answer. Therefore I could have done simply sum of answer. See that the answer reduces, almost it is equal to 1. Same way we can make it for n is equal to 20. Therefore n is equal to 1 to 20, and as usual I can take this value, and here itself I can find the sum. Therefore this also becomes 1. Approximately it is equal to 1. Therefore we have tested for n is equal to 10 and 20. Right, then this one, plot the function for yx square and its first and their second derivative and something like this. This one is a little bigger problem. So here plot the function y is equal to 3x square and its first and second derivative for -2 to -4 all in the same plot. Right. So this is very simple only. So let us clear the memory locations, clear the command window. Let us declare x as a symbol. Now the first one I plot is at plot, which one? 3x square. Therefore otherwise I could have declared the variable y is equal to 3 multiplied by x power 3 minus 26 multiplied by x, then plus 10. Right, this is my y. Now I will plot is at plot what over the plot y for the interval from -2 to 4. -2 to 4. This is my first plot. See that this is the equation of my, this is the plot of my equation. Right. Then I take the differentiation. Therefore now I take y1 is equal to, now differentiation of y. Alright. Now again I put another figure. Therefore I keep hold on, I keep the same figure, and again now this time I plot y1, the first derivative, over the same interval -2 to 4. Right, with the hold on, the older figure remains as such. Now you can see that I have two things. This is my first one and this is my derivative. Now I want the second derivative. Therefore again I take y2 is equal to, now differentiate y how many times? 2 times. Alright, now again this time I plot, again I have to keep hold on so that the old figure remains as such, and now I plot is at plot y2 and with -2 to 4. Now if I see the figure, my actual curve, my first derivative and my second derivative, all the figures are in the same plot where x ranges from -2 to 4. Right, almost the time is coming up. Therefore remaining classes, remaining problems, this we shall see in our next lecture, 7, 8, 9, 10. Hope here we have seen 6 problems, and remaining things we shall see in next lecture. Right, please subscribe my channel and please give some feedback so that I can improve it. Thank you.